So we did the law of sines, which took care of when you had two angles, right? So if you look at your notes, they mention angle, side, angle, and angle, angle, side, right? Where you use the law of sines. So the question is not so much can you do the formula for all this stuff, but do you know when to use which formula? So the short answer that works most of the time is that if you use law of sines, right, that works for when you have two angles. So if you have angle, side, angle, or angle, angle, side. So if you have more angles than sides, the law of sines works really well. Okay. However, if you have more sides than angles, right, like you have the side, 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 and the side, angle, side, that's when you use the law of cosines. Okay. So the trick is not just to know how to do the formulas and plug it in, but on the quiz, that's not this week but next week, you will get problems that say solve the triangle. It doesn't say which formula to use. By then you want to know how to pick the right formula, and usually that's the analysis part of math analysis, is knowing which one to use and when, along with all the other formulas. These are just two new formulas that you can use along with everything else. Okay, so the law of cosines, as you can see, it has like A, B, C, right? It has a lot more variables or parameters here because you're plugging in a lot of different sides as opposed to angles, right? And it has one angle, one cosine of one angle, right? So I'll show you how these work. Just like the law of sines, you can use it to solve for a missing side, like on the example 1, we're finding A. But you can also use to find a missing angle, right? So just like the law of sines, it could be used to find a missing side or angle. So we'll just go through both of those. These are three versions of the same thing, right? It just depends what you're trying to solve for, what missing side you're solving for, A, B, or C. And then you just use, as you notice here, that if you're trying to solve for A, you actually end up using the cosine of A. Right? So these match right here. And seeing that pattern is crucial to making this all work. Okay? So if I just sketch this out, if I have A, B, and C, angles, capitals, and then I have A, B, and C, lowercase, which are sides. Basically what this says is that if I want to find A, if I want to find out what this equals, I need to know what this side and this side is, and then this angle, right? So you have a side, angle, side, right? And then I can use it to find the side opposite of the angle I'm using. So that's how this, works in general. So besides that, it's very formulaic. It's just using the calculators, plugging things in, getting familiar with your calculator, making sure you know how to use it, making sure you use the same calculator regularly so you know how to punch things into it, right? Remember, it's only as smart as a user. It's not going to automatically put parentheses where they're supposed to be, and all the little details that come around with different calculators. Okay, so it's up to you to have a calculator that you're going to be using regularly and always with you for all the assignments. Okay, so let's practice this. It says round to the nearest tenth, so I want to find what A is, right? So that's a hint that I need to do the one that has A squared equals. All right, so I'm say A squared equals, and it's B and C. And in reality, B and C are interchangeable because we're just squaring them and then we're going to subtract them. So it doesn't really matter which one we call A, B or C, just so you know. But we'll keep it uniform here. So I got A squared equals B squared plus C squared minus 2A, which is 10 and 12 again. So you notice when you do the law of sines, that there's this repetition. You have like a 10 squared, 12 squared, minus 2, 10, 12, right? There's this, the same numbers repeating. And then at the end, you have what you're actually solving for. I mean, sorry, the angle you're working with. So we have cosine of 46. And this is just some big number that we're going to put in the calculator, right? As long as you put everything in the right place, you're okay. So let's look at using the calculator, and you can get yours out. And you want to type this whole thing out, right? The whole thing in there. Don't do 10 squared and say it's 100, and then this is 144, and this is 240. You don't need to put all these little details here anymore. We're just going to put the whole thing in there all at once. So we got 10, and you might have a squared button like I do right here, so that's nice. These are little things in calculators you find out over time. If you're squaring things on a regular basis, it's really nice to have that square button. Type it all in. And is this what you got? 347? Or did you get something else? Did anybody get 347? No? Oh, good. That means you're all in the right mode. So just keep in mind, if you're not in the right mode with degrees, you could get the wrong answer. So that's part of the... Did you get that answer? No, it's too big. So always check that mode. It's one of those first things, especially before a test or a quiz. I want to have that down correctly. $77, does that look right? Yeah, okay. Comes out to 77. Say 0.28. And actually that's already incorrect because I just rounded my answer, so I should make this approximately. And of course, A is going to be the square root of that, so I got to go square root this number. And it's a nice thing with this type of calculator where I can just click up here and just hit enter and automatically puts that number in the square root for me. I don't have to retype anything. So I get about 8.8. Alright. So this is the kind of work that you need to show. Just show everything being entered into the original formula. Then you could do a little bit of calculation, then your final calculation. All right. Any clarifications needed? If you feel confident, go ahead and try this example on your own. Notice how we're solving for B. So we're not going to use the same exact formula as here. It's going to be a different one because this solved for A. So there's minor adjustments from problem to problem, but the structure of all these, as you can see, are pretty much the same. And this too also is a side angle side. Check with your table group, see if you get the same thing. Squared. There it goes. We got 29.8. All right. So not too bad, right? Very similar to a lot of signs. Just using your calculator properly goes a long way. And if you get the feeling like it's just too cumbersome for whatever you're trying to do with it and the menu's too difficult, sometimes when you get those nicer or more expensive calculators, it's actually a little more difficult to do all this stuff. So, more expensive doesn't necessarily mean it's a better calculator. Still gives the same answer, right? Yeah. All right, so let's check out when you're actually solving for a missing angle, meaning you're given three sides. So up here, this is the side version. And you can solve for any missing angle. So if you have three sides, you can solve for any of the missing angles just by having three sides of any triangle. And not just right triangles, any triangle. But if you know you're trying to find measure of angle C, you have to know, well, which one of these are you going to use? So recall, if you're trying to find C, that you need to start off with C squared, because you have to know which one of those three sides is going to be squared. Right? So these things will always be on the outside. So that means I'm going to have this. I'll start off with 16 squared here. Then it's going to be 24 squared plus the 18 squared and the whole thing in the business minus 2 times 24 times 18, and back to C. So on the ends you'll have the angle and the side that's opposite of that angle. So if you ever have to figure out, well, if I want this particular angle, how do I know it goes in front? Well, it's the side opposite of it. And then we have to solve this, right? So we have to do this in 2 steps. And believe it or not, this is kind of like a 2-step equation. So before I do that, it's almost like I have, like, I don't know, 8 equals 2 minus 3x or something like that. To solve that equation, I'd first subtract the constant numbers, right? I'd subtract 2 on both sides. Then I'd divide by whatever's in front of my variable. So on this particular problem, right, all of this, that's what I'm going to subtract. Like here I subtract 2 on both sides. On this one I'm going to subtract 24 squared and 18 squared. And then like I have the negative 3 right here, I divide both sides by negative 3. On this one I'm going to divide by done. And divide by the negative 2, 24 times 18. Okay, so those are the steps. We got 16. I'm subtracting this blue part, right? So if it's 24 squared, it's going to, when I subtract it on both sides, it's going to be minus 24 squared. And 18 squared will be minus 18 squared. Equal negative 2 times 24 times 18 cosine C. Now, if you really wanted to, you could do 24 times 2 times 18 and get the one number. It's just a personal preference if you want to do that or not. But the next step is to divide both sides by that coefficient. Whatever's in front of the thing you're solving for, that's what you divide by. Right? Just like negative 3 is in front of x here, so we divide both sides by negative 3. We're dividing by this whole thing. It's kind of nice leaving it this way because you can see some patterns show up that you wouldn't normally recognize. That all cancels. That number cancels that number. Okay. And you can see there's 16 squared minus 24 squared minus 18 squared, and below it you have negative 2 times 24 times 18. So you'll notice there's a pattern to these where the same number is kind of lining up somewhat. So it kind of lets you know that, okay, everything's in the right place. All right, so cosine, this equals cosine of C. So once again, since our answer is an angle, right, the answer is an angle, that's how you know you need to use the arc cosine. Right, so what you really are doing is that you're taking the arc cosine of both sides. You do that to both sides. And the cosine and arc cosine cancel each other out, and you're left with just C. All this stuff just cancels out. You're left with measure of angle C. That's what we're trying to find. And we have this big old thing, right, that we just need to put in the calculator. So once again, you have to, make sure you're typing everything in correctly. Arc cosine. For this one, I just press cosine twice. It's really easy. I highly recommend, if your calculator has a fraction button right now, to find it. So like my fraction button's right here. All right, if you press that, it makes it a lot easier to make sure what's on the top and what's on the bottom. If your calculator doesn't have that, you have to add more parentheses. All right. So if your calculator doesn't have a fraction button, you're going to have to do a little more inputting, and you have to do parenthesis, arc cosine parenthesis, and then a parenthesis again for just the top, and you hit the divided by button, and then you do parentheses for the bottom, and the very end you have to close the parentheses again. So without the multi-line math input like we have here, you have to be a lot more careful with those parentheses. So we got 16 minus 24 minus 18, squared, all squared, on the bottom. And I don't require that you actually show me what this big old long number is. It's some big negative number, obviously. You don't need to show me what that is, all those in-between steps. We're not concerned about seeing all the arithmetic and the in-between. We just want to know what the whole thing equals. And I can close it off. Okay. Do note that this negative sign right here, your calculator may have a negative button. So you can't use the subtraction sign for negative numbers. Like on mine, I have a negative, right here, there's an actual negative button. So there's a subtraction button and a negative button. If you get something that says syntax error, it's probably because you use a subtraction button instead of the negative button. Or you might have some parentheses that you need to add in order for it to understand what you're doing. So that comes out to about 41.8. Okay. That look good? So far so good. Check your calculator, make sure you know to put everything in. Find the fraction button if it has it. Usually if it has a taller screen like this one, it does have a fraction button, maybe in a different place. It might say, it might be N over D. This one has like empty box over empty box, so they might look a little different from, you know, maker to model and whatnot. So you want to make sure you know how to use the one that you're going to be using regularly. And when you're ready, go over to the right and practice on your own on number 2. I think the biggest step here is just the first step. You got to know how, where all the right numbers go, and then the solving is, solving an equation you've been doing for years and years and years. Since I'm solving for A, I know A goes first. Okay, so you should get like 99.6 thereabouts. How does those look to you? Look good? Is this easy? If you got a quiz on this, do you think you'd do okay on it? Not too bad. Only problem is both these answers are wrong. So who caught it? Anybody catch it? A few people caught it. What did I not do? Yeah, I didn't read the directions. Round to the nearest minute. So this is a fallacy when you come to something that you're like, oh, this is easy. I kind of get this. This quiz is going to be 100%, and then you get it back and it's a 77%. And you're like, oh, I forgot all the little things. So it's great to get this far, but let's keep on going. So we need to convert these to the right units according to the directions, right? So don't step on your own toes here, right? So 41 going to be 41 degrees. And 0.8. So this is basically saying what's 80% of an hour? How many minutes are 80% of an hour? All right. So we take 0.8 times 60 minutes. All right. We're saying what's 80% of 60 minutes? That'd be 48 minutes, right? So 48 minutes. So if anybody asks you, well, how long would 80% of 1 hour last? You know, how long is that? Well, it's 48 minutes. All right. So that's what measure of angle C equals, and that's the answer we'd want to go with. Okay. And then same thing over here. It's going to be 99 degrees, and this is saying what's 60% of 1 hour? How many minutes is that? So that one you could probably do in your mind, right? 6 times 6, 36 minutes, right? 60% of an hour is 36 minutes, which makes sense. 50% of an hour would be a half hour, 30 minutes. So 10 more percent, 6 more minutes, right? So it's not that it's difficult to get the right answer. You have to read the directions to make sure you know you need to do that. Okay. And the last one is just throwing it all together and using everything at the same time. So law of cosines, when you have more sides than angles, right, use the law of cosines. There's this little thing right here about making sure it's actually a triangle before you do this. I think everything you're going to be given is going to be like actually a triangle, but all this means is that you have to two sides you add together must be bigger than the third side. So for instance, if I said like this has like a 5, 6, and 7. So 5 plus 6 is bigger than 7. 6 plus 7 is bigger than 5. Right, 5 plus 7 is bigger than 6. Like every combination, if you take any two, and you add them together, it's bigger than the third. So for instance, if this C was 11 instead of 7, well, 5 plus 6 isn't bigger than 11. 5 plus 6 equals 11. But this wouldn't actually make a triangle. Physically, it could not be drawn. Or this is 12. Anything bigger than 11 or bigger, like this is not an actual triangle that can be drawn, right? So, but everything you're going to be given, I think, has, you know, actual real measurements, right? And of course, if we have two angles, we have more angles than sides, we're going to use law of sines. Now, the thing that we have not gone over, that there's some ambiguity, kind of like with when you guys are graphing parabolas. Sometimes you could have 0 solutions, sometimes you could have 1 solution, and sometimes you could have 2 solutions, right? So any given quadratic had a possibility of having 0, 1, or 2 solutions. This shows up when you have 2 sides in an angle, but the angle isn't included, right? So it's side, side, angle. And you might remember this from geometry. There are 4 congruencies, but your teacher probably made a good point of saying you can do side, 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 you can do side, angle, side, you can do angle, side, angle, 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 side, but you can't do angle, side, side. Doesn't work, okay? This does not work necessarily. You get multiple ways of doing it correctly. That's why there was not a congruency theorem, is because it didn't work exactly. Like you couldn't say it's congruent because the triangle could be drawn 2 different ways with the same information. Right? So in short, actually I'll draw this. So in short, if I'm given a side, angle, right, this is a possible, and this is possible. This side could be 2 different lengths, and that's why there's 2 possible different triangles with side, side, angle. We'll look at this on Friday. This whole thing is going to be its own special day on Friday, on how do you know what the possibility are. If there are 2 answers, how do you get both? Right, so meaning This angle could be an answer, but so could that angle, and they're different measurements. You have to know how to get both of them. Okay? Or it's possible that this length is too short and it doesn't reach. That's how you get your no solutions, which I kind of touched on already with the triangle inequality. So that third side does have to be long enough. Alright, so let's just solve this. I think this is a fully doable. And they may not be drawn to scale, but we can see one side longer than the other. Okay. Now, one little detail here. There is a correct one to figure out first. So you're looking at these, like you need to find all the missing angles, right? That's what it means to solve. So we have 3 missing angles. We have 3 sides already. We have to find 3 missing angles. And with the law of cosines, you can do that, right? That's what we just did here. We had 3 sides, find the missing angle. But you have a choice of which one you want to find. Down here, it makes a little note. It says, for side, find the largest angle first. That will help you not mess up with the ambiguity of having multiple correct answers and things like that. So while it might look like, well, I could just pick any one of these to start off with and go with that, you really want to start with the biggest angle, which of course is across from the biggest side. So whichever the biggest side is, you're going to do that angle first. So this is C. So that means I'm finding angle C first. Then I can find the other two in any order I want. Small but important detail. And it's one of those things that, like, if you didn't do this, you probably wouldn't even notice. It probably wouldn't come out the wrong answer 99% of the time. But you will be tested on this, so make sure you do that. So there will be a problem that actually comes out wrong if you don't do this correctly. So choose the biggest side to get the biggest angle first. So I want to do C. So my first thing is going to be a law of cosines, 7 squared. Yeah, and just go through the same thing you've been doing. 5 squared plus 6 squared minus 2 times 5 times 6. Cosine of C. Now for me, you kind of notice on that last example, I kind of just skipped to doing all the algebra, recognizing that there's a pattern to what this looks like. It doesn't change, right? So if you can do that, that's fine. If you want to show all the work of, oh, I subtracted this squared, I subtracted that squared, then I divided by -2, and then I divided by these numbers, and those are always on the bottom. If you want to show all that because it makes more sense to you, you can. I am okay personally if you just kind of skip to this and say, alright, the measure of angle C, is going to equal this whole thing. 7 squared, and then you would subtract 5 squared on both sides, subtract 6 squared on both sides, and then you would divide by -2 times 5 times 6. If you're comfortable with that, I'm okay with it as well. This step does need to be written though. So remember, the last step before your answer should be what you're actually putting into the calculator. So this right here will match exactly what goes in here. So if you need to ever retrace, how did I get that answer? All right, how do I get this approximate answer? That's a single number. The step before that should be the exact thing that you put in the calculator. Of course, I forgot something, didn't I? After all that yapping. Forgot the arc cosine. Without that, we won't get an angle answer, right? So I need that arc cosine in there. All right, fraction button. We get 78.5. we go. And this does not say to change it to DMS, but if it did, when it's 0.5, it's kind of nice. Hopefully you guys all know what a half hour is without having to do a calculation. But if it did ask, we'd know that half hour is 30 minutes. 0.5 is the same as a half, right? So it didn't ask that, but it's there anyway. But of course we're not done. We need to find A and B. So it's up to you. Now it's truly up to you. You can find A or find B using the law of sines. Right? So we now have a side and its angle counterpart. Right? So now I can use law of sines and say sine of what we just found, 78.5, over 7 will be equal to, and you get to pick. You could put sine of A over 5 or sine of B over 6 and find the angle. I'm going to go with, let's say, sine of B over 6. Cross multiply and divide. So this part will be on top when I cross multiply, and I'll divide by 7. Right, so I'm going to have sine of B equal 6 sine of 78.5 all over 7. Therefore, the measure of angle B will equal the arc sine. Yeah. .1, let's say. Should be about 57 and 6 minutes. 7 degrees and 6 minutes. Of course, if it's 6, I wouldn't put just 6. I put 06. 10% of 60 minutes is 6. Oh. And now we have three angles. 57.1. Angle B. So angle A, you could go back and do law of sines again and do what we just did. Just switch it for angle A and 5 instead of 6. Okay. So that will work. Or you can go back to elementary school. We have two angles of a triangle. What's the third one? It all adds up to 180, so you could do that as well. So it's totally up to you. Personally, I like the idea that the measure of angle, what are we on, C? Looking for? No, A. Measure of angle A will equal 180 degrees minus the other angles, right? So the one we just found of 57.1 minus 78.5. And if you're one of those that, when you have extra time on a quiz or a test, you know that you can do this problem another way and double check to see if you get the right answer. Oopsie, what did I do? I'll use the subtraction button. There we go. What did I do? 57.1. 0.1. There we go. 44.4. Which 4 times 6 would be 24. So there you go. And you can double check the minutes. 24 plus 6 is 30. Plus 30 is an hour. So yeah, those all add up to 180 degrees. Alright, cool. Okay, ignore this part down here. You're not doing this. I'm just going to give you a different worksheet. If you feel motivated, go for it, but not necessary for me.